In this video, I am going to go over parts of the respiratory lab that you have notes for, but I want to go through a more detailed explanation so you'll hopefully have a better understanding of it for the test. So I'm going to start up here with the pleural membranes. There are two layers in a space, so you've probably heard of the pleural cavity. Okay, the pleural cavity is actually the space between the two pleural membranes. So the parietal pleura, this layer, attaches to the thoracic walls. So imagine where your lungs are in your chest, and against the wall of that thoracic cavity, you have the parietal pleura. The visceral pleura, visceral meaning organ, is the layer of the pleura that is attached to the lung. And then the space in between is called the pleural cavity. And there is moisture in there that allows your lungs to expand. Okay, allows your lungs to expand, provides lubrication there so the lungs can expand and get smaller as you breathe, deep breaths. Okay, you have that movement there. So that these are going to be important when we get to why some air always stays in your lungs. So we're going to go into inspiration and expiration. There are two basic laws, so I'm pretty much just repeating this, but then I'm going to show you a picture that will hopefully help. Pressure and volume are inversely related to each other. So what that means is that as you decrease the volume of an area, the pressure increases. So take a balloon that is filled with air and tied at the top. And if you squeezed it, okay, if you squeeze that balloon, what's happening to the balloon is the volume is getting smaller, the volume's decreasing, and the pressure in that balloon is increasing. Okay, so the volume is decreasing and the pressure is increasing. That's what we mean by inversely. They are going in opposite directions. So if you increase the volume of an area, you are decreasing the pressure. So they go in opposite directions. The second basic law you need to know is that air travels from an area of high pressure to low pressure. So we've had this concept in lecture and lab. Things go from high to low. Things go from high to low. So the way that your lungs can change the pressure is by changing the volume. If you decrease the volume of the lungs, you're going to increase the pressure in the lungs. If you increase the volume of the lungs, you're going to decrease the pressure. And what's actually going to cause the volume of your lungs to change is going to be the diaphragm, okay, that muscle, that main muscle of breathing. Okay, a couple more definitions here. Atmospheric pressure is the pressure outside the body. Intrapulmonary pressure is the pressure inside the lungs. And the intrapleural pressure is the pressure within this pleural cavity. So I'm going to go back and forth here. So atmospheric pressure is out here, intrapulmonary pressure is within the lungs, and intrapleural pressure, which is hard to show you on this, is in that pleural cavity that surrounds the lungs, okay, that surrounds the lungs. All right, back here. So what we're going to do is I'm going to talk you through the process of inspiration, then I'm going to show you the picture. Hopefully that will help you visualize it better. So the process of taking air in is an active process. So there's going to be a signal from the medulla of the brain, which is going to signal the diaphragm to contract. Let me show you this picture. Okay. So when the diaphragm is at rest, it looks like this. Okay. When it looks like this, it's domed. When it gets the signal to contract, it moves down, it flattens out. Okay, so when it contracts, it flattens out. Now, think about when it flattens out like that, what is it doing to the volume in your lungs? What is it doing to the volume in your lungs? What it's going to do, it's going to increase the volume of the lungs as it flattens out. Because we're increasing the volume, we are decreasing the intrapulmonary pressure. So we're expanding the lungs, increase the volume, decreases the intrapulmonary pressure. What that does is it changes the intrapulmonary pressure. The intrapulmonary pressure becomes less than the atmospheric pressure, and air is going to travel in the lungs. So our body can't change the atmospheric pressure. It can't change the pressure out here, but it can change the pressure in the lungs. So again, as the diaphragm contracts, it moves down, it increases the volume, it decreases the intrapulmonary pressure, so the pressure out here is less than the pressure in the lungs, and air will travel in. So that is inhalation. It's called an active process because the diaphragm and some other muscles are actively contracting in order for it to occur. That is inspiration or inhalation, either one. Expiration is a passive process, and this is because it's just going to involve the contraction of the diaphragm, so and the other muscles that may be involved. So the diaphragm is going to relax. When it does that, when the diaphragm relaxes, it's going to go back into its dome position. So contract here, relax up into a dome position, which is going to do what to the pressure in the lungs? So we're decreasing the volume. So that means we're going to increase the pressure. So now the intrapulmonary pressure right here becomes greater than the atmospheric pressure, because again, our body can't change atmospheric pressure, but we can change the pressure in the lungs. So the intrapulmonary pressure here is greater than the pressure here, and air is going to leave the lungs. Okay, air is going to leave the lungs. It's called a passive process because the muscles are just passively relaxing. Okay, so no matter how much you breathe out, how much you try to get all the air out in your lungs, you will always have some air left. So you can breathe out and say there's no more air in my lungs. In reality, there is. Okay, there is. The reason there is because of the interpleural pressure that we talked about before. So up here I showed you interpleural pressure, oh, right here. Interpleural pressure in this pleural cavity is the pressure between those two membranes. So that interpleural pressure is always going to be slightly blank than atmospheric pressure, keeping some air at the lungs. So there's a relationship between interpleural pressure and atmospheric pressure that keeps air in the lungs. So what you have to think about is the interpleural pressure going to be higher or lower than atmospheric pressure. So I'll give you a second to think, turn the video off, think for a second, and then I will answer the question. Okay, and now we're back. So intrapleural pressure, air travels from high to low, from high to low. So what's going to happen is that the intrapleural pressure is always going to be slightly lower than atmospheric pressure. So this is higher, this is lower. Some air is always going to stay in the lungs because of that difference between the atmospheric and the intrapleural pressure. Now, when you hear about a collapsed lung, or the technical word is a pneumothorax, what happens is, for some reason, and the most obvious one to kind of visualize, someone gets stabbed by a knife. What it's doing is it's stabbing through that interpleural membrane, and what's going to happen, because air travels from high to low and the outside atmospheric pressure is higher than within that interpleural pressure, air is going to travel in there, and what's going to happen is that's going to cause the lung to collapse because we're neutralizing this difference. Okay, we're neutralizing this difference. So that's what happens with a collapsed lung. You can survive a collapsed lung. You have more than enough ability with your other lung that it can compensate for it. But I can imagine if it happens that it's probably pretty scary because you're not going to be able to take in as much air. What they'll do is they'll put a tube in there, and then they'll get that pressure back into the interpleural pressure so that that difference now exists. Okay, the second thing I want to go over is the volumes that you need to know. Okay, the volumes you need to know for respiration. So you have the list of them, but you do not have their definitions, and I'm going to go through the definitions. First of all, a spirometer is anything that can measure lung volumes. It can be relatively cheap. The ones we have that you're not going to get to see, at least this semester, spring of 2020, are relatively cheap. There are other ones that are incredibly expensive. So some of these volumes are easier to measure than other ones. Okay, so here are the different volumes. You have this graph here you need to look at. I will say the definition 2 or 3 times, but then if you can't, you need to stop the video then and write it down. Okay, don't think, oh, she went too fast. Remember, I'm a video now, so you can always rewind me. Okay, so tidal volume is the amount of air that you can inspire or expire per breath. Again, it's the amount of air you inspire or expire per breath. So when measuring tidal volume, you're usually going to choose inspiration or expiration. Obviously, it is easier to measure the amount of air you expire than the amount that you inspire. So again, tidal volume is the amount of air you inspire or expire per breath. Next volume is vital capacity. Vital, and here, let me go down here and show you this. Here's tidal volume, the amount you inspire or expire per breath. Okay, there you go, right there. All of those are tidal volume. Vital capacity is right here, from here to here. So let me show you what happens. And I'll say the definition as I show you this, and then you can write it down. So vital capacity is the amount of air you can expire after maximal inspiration. So maximal inspiration, and then you blow out as much air as you can, and that is vital capacity. So again, definition, it's the amount of air you can expire after maximal inspiration. The amount of air you can expire after maximal inspiration. You take in as much air as you can, and then you blow, 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 blow out until you have no more air that can leave your lungs. That is vital capacity. Okay, that is vital capacity. So vital capacity is just an amount, the amount of air you can get out. Forced expiratory volume is the same definition. Okay, so same definition. Here, you're trying to push out as much as you can, as fast as you can. So forced expiratory volume, just go with the same definition as vital capacity. But then here, what this is, forced expiratory volume, we just kind of shortened it here to FEV1 over FEV. This is going to be a percentage. This is going to be a percentage. And here's the definition for this one. It's the amount of air you can expire in 1 second. Okay, it's the percentage. Let's start. Let me do that one again. It's the percentage of air that you expire in 1 second after maximal inspiration. Okay. So you take in as much air as you can, and then you blow it out as fast as you can. So obviously this is going to take a more sophisticated spirometer to do this, but it is the percentage of air that you can blow out in 1 second after maximal inspiration. Okay, after maximal inspiration. You take in as much air as you can, and then you blow, blow, blow out very quickly, fast, and this is the percentage that you can expire in 1 second after maximal inspiration. So this can be used as an indicator of lung health. A smoker will get a lot of mucus buildup over years in their lungs, and with that mucus buildup, what can't happen is they can't get air out of their lungs as quickly because there's more resistance to that movement of that air. So that's one way when you're comparing lungs to a healthy person versus a smoker, their FEV1 over FEV over years is going to be less than someone who doesn't smoke. Another example of when it can be used is someone who has severe asthma. When they start, they may not even know they're going to have an asthma attack, but what will happen is they get an inflammatory response in their bronchioles, which means they can't move air out as quickly. So some people that are severe asthmatics, they actually have a spirometer at home, and every morning they will measure their FEV1 over FEV. And if the amount of air they can get out in 1 second starts to go down, that tells them that they have an irritation in the lungs and that they may need to up their medication. Okay, so this can be a good indication of lung health. You can also have FEV 0.5, how much they can get out of their lungs in a half a second, 1.5, 2. All right, so you've got different numbers you can use here, but we'll focus just on one. Okay. Residual volume, which is represented down here, is the amount of air left in your lungs after maximal expiration. Again, it's the amount of air left in your lungs after maximal expiration. So even though you've blown out all your air, there is still air left in there, and that is called the residual volume. Now, why does that air stay in there? We go back to up here, okay, to these and these different pressures, and that pleural cavity keeps some air left in your lungs, and the air that is left in your lungs after maximal expiration is called the residual volume. Okay, that's called the residual volume. Okay, so that should finish. That should help you get through the rest of the respiration lab besides just the basic anatomy. Okay, we'll talk to you soon.